All right, hello. I do believe we are live. Uh, Hi. So today I have open right now my portfolio of all of the various projects that I have ongoing, and you can tell that they're at all kinds of different stages. And then here you can see I have reading as well as new project ideas. Um, and today I want to talk about what it's like to start a project. Um, and then after we talk about what it's going to be like to start that project, I want to actually create that project dashboard, I guess you could say. Okay, I know it's been a while since we've been live. Uh, and I apologize for skipping a week, but my parents were in town and I wanted to enjoy their vacation with them. But I'm back this week. So we have been working on this project called Tracking Potential Solvent Interactions. That's something that I've been doing on my Wednesday live streams. So I'm going to go ahead and update this overall kind of tracking that we have going on. I still have not updated the project description. There is no presentation yet for this project because it is in progress and not completed. Um, the notebooks now have more descriptive names, but I'm going to keep this unchecked as this is something I want to ensure that is completed at the end of the project as well. I also want to make sure that the data has a descriptive name at the end of the project so that that can be packaged as a release. Um, as far as obtain, have we considered external data sources? Have we imported libraries? Again, this obtain, I'm going to keep that import libraries unchecked because whenever we create the application at the end, we want to make sure that we package all of the libraries that are going to be used in the project inside of a specific system. Have we considered external data sources? We have considered them. We have not necessarily brought them into the project yet. So I'm going to leave this particular box unchecked. Here I have a comment, find information on which type of regression will be best. And here I'm just going to put a thumbs up because I feel like this has been completed in the project so far. Okay. You should see here in a little bit that our obtain card will turn white, meaning that we have interacted with it recently. As far as our scrubbing, we have cleaned up column names. I believe our next step is managing nans, duplicates, infinite numbers. We have not yet considered whether to backfill, forward fill, or fill by average. And we have dropped unnecessary data so far. I think we've done that. Let me just double check our project dashboard here. So here's our scrub. We have evaluated data types and cleaned up column names. Here under drop unnecessary data, I have this comment. I want to drop, oh, that's not proper English. I want to drop unnecessary data so that inherent data bias is removed, improving model performance. When I view process data, each row and column is there on purpose and has been evaluated for inclusion into the process, the final process data. We haven't done that much yet. We haven't gone that deep into it yet. So I'm gonna actually go back into our project dashboard here for that particular project, which is here under Scrub, and I'm gonna leave that unchecked. We have not yet hit the Explore or the Notebook categories as of this point in time. So I'm gonna leave that update where it is, and I'm going to start a new project. So here I have this list of new project ideas. You can see I haven't touched on a lot of them in a long time. This I'm going to call battery storage. This is a project that my partner and I talked about over the weekend. I want to make sure that my project title is just as descriptive as my better titles here. So arima modeling, that is a verb at the beginning, which I like. Classifying gene locus by protein composition, that is also a verb at the beginning with a lot of things in it. And then our current project has a verb at the beginning, tracking potential solvent interactions. So this battery storage project, what it boils down to is this is creating a system for long-term battery storage. And what that looks like is whenever you grab a battery, you want it to be at 100% so you can use it for a long period of time. However, batteries are not optimally stored at 100%. Their optimal storage is somewhere between 40 and 85%, I believe. Don't quote me on that. I am not the person that knows this kind of information for this project. I am definitely the coder, not necessarily the person with domain expertise. That is definitely my partner. But what they explained to me is they want to be able to charge batteries up and then allow them to discharge while monitoring their charge level and being able to set a threshold to which batteries are allowed to discharge before the system automatically recharges them one at a time. So basically, this long-term storage solution would have a set of cubbies that have your variety of battery needs for your household, AA, AAA, drill batteries, uh, other types of batteries that are used in flashlights, like basically any type of rechargeable battery, including ultimately what could turn into a phone battery, which would be interesting. Um, anyway, regardless, this is a series of cubbies that house an individual battery, um, and the system that's connected keeps the voltages and informs the user through a series of LED lights what the battery charge status is. If it's green, it's close to 100% and can be used. If it's, we've been arguing about the color, whether to get blue or yellow. I said blue for storage because it's like it's frozen. My partner's like yellow because it's not fully charged, and I'm like, that's confusing because it's not actively being charged either. Anyway, regardless, there's an LED indicator for, you know, this is ready to go, this is in storage, or this is not charged, don't use this. Um, and so that's kind of the idea. So this is a new project. Over time, we talked about doing a couple different levels of the project. One is just the basic, let's just get AA and AAA out there in the world because people use those all the time. And then we talked about getting deeper into drill batteries and so forth. Um, and then we also talked about a potential for people to collect their own reports on batteries and their lifetime and figure out basically whenever a rechargeable battery is entering end of life. That way people can plan and accommodate and plan for purchases of larger uh, rechargeable batteries. You know, some drill batteries run upwards of $100, and that can be pretty expensive if you're not expecting it. So that's the idea behind this battery storage project. Is this a data science project? Not necessarily at the moment, but it could definitely turn into one. Okay, so what I want to happen is I want to call this project determining voltage status I want to say something like and acting on said status, determining voltage status for charge or for charging or for recharging batteries. I feel like that's pretty descriptive. And I'm gonna put this after my most recent project there. And then there's a couple of things that need to happen from our templates. So I'm gonna go ahead and add a car, hold on. I forget how to do this sometimes. Let's go into our template card. Then we can create a card from the template. We want this to go under the list determining voltage status, create card. Cool. And now we have this here. For our repo, we have our to-do checklist. We have a general idea for how to create that repo status. I love this website. We'll be looking at it here in a little bit. I want to go to obtain. Now, this is going to look a little bit different because we're not starting out as a data science project. We are actually, this is going to end up being a Python project first. It's going to end up being a software dev project first. So Scrub, we're still going to need to make sure that our inputs from our, I think we're going to end up using a Raspberry Pi. We've been talking today about what microcontroller to use. And I think we're going to go with Raspberry Pi Pico. We explore. I don't know if we're going to need to do any of this, but I'm going to include it just in case. Ultimately, we're going to be calculating for a percentage based off of a maximum. More on that later. As far as model tuning, visualization, wow, this is not a great template. We talked about generating reports and sending them via Wi-Fi to yourself. That's something that I want to get to later. This card isn't even in it. It's not even a template card. Make a template. So I'm gonna add this. And then we have notebook. What's kind of ironic is like I'm not even gonna be using a notebook for this project, I think. I think I'm gonna be solely in VS Code. But we still want things. We still want some general Pi file practices. So I'm gonna create this card. I might end up renaming it. I think I'm actually just gonna rename it to Pi files. That way we just have our QC for our Pi files. That's kind of what this is, by the way. This is definitely a QC type thing. Under deployment, you can see that this doesn't have anything on it. So I'm gonna create, hold on. There's something I know already. Not a label, checklist. And I think we've just been calling them to do. And we're not gonna copy items from anything. Just let me make sure. Hashtag to do deployment. We're gonna call this hashtag to do the same, just the same way. And one thing I know for sure that we need to have for deployment is we need to have our requirements.txt file. We need to have our .yml file. We need to have if it's a web application, and I think that's the route that we're going to go for this project, is develop a web app that you can interface with your project through. Then you need to have some JavaScript. You need to have your CSS files, and you need to decide if you're doing a Django or Flash style project, and you need to just have that ready to go. Those are things that I think are the minimum must-haves for this project. You need to have your landing page. You need to have your 404 page. And this goes into the HTML for that. Um, and then there's a big thing too, and this is something that I'm definitely still learning, which is architecture of the whole thing. Like how do people get to your website? What server is it hosted on? Is there any sort of container that needs to be done? Does a Docker need to be set up? So these are definitely questions for deployment. Uh, and I think it's so hard. I hate jumping into a project and uh, but you just have to start, right? Like my repo stuff, the reason why I have this list of stuff is I started making a list. Okay, what do I need to double check for all of my repo information? And then as I've done projects and started using it, I've kind of been able to refine my list. Um, okay, so first off, to start this project, the first thing that we need to do is make a repo. Um, and that's gonna look like some things. Okay, I'm gonna go ahead and hide my uh screen here right quick, just because I'm not sure if I'm actually logged into GitHub or not. Okay, cool. Okay, this is my GitHub page for repositories. And you can see here that I have a project. This is a private project. I don't know why it's private if I'm streaming it on YouTube. I don't know. Regardless, I have a private project with chromatography. And you can see this tracking potential solvent interactions matches tracking potential solvent interactions. So that's what I want here is determining voltage status for recharging batteries. I want to make a new repository. Okay, cool. Home, delete determining. Description. I want to go ahead and include this. These repo names suggested by GitHub make me giggle all the time. So this project, this is just going to be like a basic description statement. It's not going to be my final one, but I want there to be one on there. This project is to set up a system that interfaces micro controllers and user configurable options for user configurable options to store batteries for a long time period. The system will provide storage information via red, green, blue, LED lights about will provide storage information via RGB LED lights about battery status, i.e. not charged, charged, stored. I want to make this a public repo. We talked about whether or not we wanted this to be open source, and we definitely do. So this is going to be a public. I want to add a README. I want to include a Python uh, git ignore template, and I want to license this under the MIT license. I'm actually gonna pop into the chat with my partner about this project, and I'm gonna tell him that I'm registering this repo with an MIT license. And something that you can do a whole bunch of different types of licenses. What I like about the MIT license for GitHub, uh, choosing the right license, determining this is the list of licenses. I think I mentioned I like the MIT license. I would like to read open source. Yeah, this is why I like the MIT license. It's very short, it's easy to understand, and it's open source. You can do anything as long as they keep a copy of the original license, including the copyright notice, which is included in the MIT project by selecting the MIT license here under choose a license. Um, it will have dependencies. Uh, so, yeah. Anyway, I like the MIT license. Um, I think here, yeah, free of charge to any person, the software to deal in the software without restriction, including without limitation, the rights to use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software, and permits persons to whom the software is furnished to be able to do so the following conditions. The software is provided as is without warranty. So basically, it's protection. Um, for the users or the creators, which in this case is me. Okay, so I want to create this repo. I have a description, it's public. I want to add a README. Right now, that README will just contain this optional description. I want to use the get ignored template associated with Python because I know that I'm going to be using a series of Py files for this particular project. MIT license, I'm going to create this repo. So the reason why I'm showing this as the quote unquote manager is because I can now add people to this project. I'm gonna jump right in. Add projects to view them here. I don't want to link any projects right now, but I do believe I can add a collaborator. I don't know why I need to confirm access again. I'm just turning my phone off or the video off for a quick second. Because I'm being told to authenticate my account. I believe, yeah, there it is. Okay. Okay. I authenticated. I can now add people to this project, and this would be, anyone else that is working on the project. And then you can do moderation, you can do code review limits, you can set interaction limits. There's a whole bunch of stuff that you can do now that you have this repo started. some of the consequences of what we did in the beginning. We have our description over here, and right now that's all that's in this README is that description. We have our MIT license, which is the same as we looked at on the web page for licensing. And then we also have this git ignore, which includes a bunch of things. We have our Py file ignore stuff. We have our SQLite, which is good. We have our Python version, .sage.py. There's a whole bunch of stuff in here. Our .py, and then we have in brackets. And then we also have the Py class. What's going to be interesting to me is to see if our Py files actually update or not. So we have this repo. We have created this repo. So under repo, we have a git ignore and we have a license. That's all that we have so far. We have a project description, but it's not very good. It's something that I'm going to want to revisit to describe the project in more detail as it unfolds over time. Then our file directory. This right now just exists on the internet. I have not actually made this on my local computer. And so I think I have a terminal source here. I do. I do not have any terminals at the moment. Let me terminal. There we go. Okay, so we have a terminal here. So I want to navigate to the place where I want to store this file. This is something that you may or may not do as a manager, but it is definitely how your data scientists and your software dev people are going to start a project. Is first they're going to set up or get access through the cloud, and then they're going to install a local copy on their own laptop and or computer. So I'm going to navigate to my home directory, to my desktop, to my folder that's labeled data science. And then within that folder, I have this folder called projects. These are the projects. I want to make a new directory. Is it that? Oh, it's been a long time since I've done make directory. And then I want to call it determining voltage status for recharging batteries. Haha. And then I want to navigate into that folder, and then I want to clone shift insert. Yeah, I want to clone the repo that I just created inside that folder. Okay. This always happens to me. Okay. Okay. I put a file inside my folder. Or I put a folder inside my folder. So I'm gonna go ahead and fix that in my actual structure right quick. Projects. Let's see here. Okay. And now it should be live. Okay, so that means that my I do the git status afterwards, after checking to make sure that my contents are there, because I want to make sure that what I have locally is connected to what I have available in the cloud. So now I can do things like create a new branch that says, you know, starting a project, and make modifications from there. However, that's outside the scope of what I want to talk about in this particular stream. So I have my repo, it's been started. This project is officially off the ground. So I want to go over here and make a new board. This board title, I want to be determining voltage status for recharging batteries. I want to create this in the workspace. I visibility workspace, you can make it private, you can make it public. My workspace is public. So I've got this workspace. You can see I'm a part of a different project as well. I have 7 boards remaining. My background, I don't care. Some projects have specific art that can be cool to include as the background. I'm going to go ahead and create this. Now I have a brand new board that has nothing in it. So what do I do? So here we have our first list here. I think I'm going to add a list and I'm going to call it project components. And then I have another list here called sprints. I want to turn this into a list as well. I definitely want sprints for this. Then this is where stuff is going to get a little bit different from our data science work, but you can tell that these list titles actually come from these cards here. And so I want to do the same thing here. I want to call my first one repo. And I think my music stopped. Yeah. Let's go to the next page and let's continue our music. Okay. And this is what I think is really cool about Trello in particular. So I have repo, I have obtain, but I can also go here, I can add another list. How do I do that? I think not there. I want to be here. Then I want to go to obtain. And I can copy this to board. I can change the board that I'm copying to. And I want this to go This is really interesting. I'm going to see what happens. I'm going to create this card. Then I'm going to go to this board, and you can see I have obtain here. Can I drag it to be its own list? I cannot. So I'm going to put obtain here. And then I'm going to delete. I'm going to archive that card. But I can put obtain here. And I think I can copy list. Nope. We'll get to that here in a little bit. I know that the next thing is scrub. Then I have explore. Then I have model, which I don't know if I included that in this particular project or not. Let's double check. I do not have model. I do have visualization, py files, and deployment. Visualization, py files, and then deployment. I'm going to move this py files next to the repo. It's something that you kind of do at the beginning, and then you want to wrap around back at the end to make sure that everything's kind of in order. And then deployment's going to be the very last thing that we do. We want to get our Pi files set up first. So our project components, I'm going to copy this card to the board determining, and I want this to go to project components, users. I want to copy this card. I want it to go to determining. I want it to be in position 2. And then project description. I want to copy this, and this isn't a card, this is a list technically, I guess. Create, well, I guess it is a card. Okay. So now here we have some information. And this is what I want to get into the nitty gritty here today. And then I want to, is there any way for me to delete? I don't think there is for me to delete that particular comment. Show details. No. No, there's not. Okay, that's just gonna exist there apparently. Okay, so project description we've talked about. We do have a project description. So we're going to put that here, and whenever we get to this part of our project, we probably will end up writing that better. But let's talk about user stories. There's a couple of things that happen with user stories. We have user roles, we have activities, we have business values. The description clearly articulates what functionality is being developed, why, and for who. So we need to make sure to address these 3 questions. What functionality, why, and for who? And this is kind of the basic structure. As a user, I want activity, so that business value. And then afterwards, you write an acceptance criteria written to be testable to ensure requirements are met and software functions as expected. This is really important because we want to be able to test what we're doing. Then after that, acceptance criteria, the way that it's written is actions and then expected results. Then after that, we get story points assigned by the dev team. This is an example. As an end user, I want to input an image file so that I can create cross-stitch patterns. When I drop the image into the application, it should let me know if the upload was successful. That is an example of a user story. It does not have the acceptance criteria or the story. It does have story points associated with it. But that's what we're going to start developing for this project. And that's what we're going to start moving into to create these sprints. So this is another thing. The users, we have to define what the users are going to be for this particular project. And I can't delete comments from there either. Okay, cool. Yeah, so this is how we're getting started. There's something that I want to pull up. The IDE that I am most familiar with at this point in time is timeline, explore. File. Open folder. I want to open up a new folder in my Explorer. I want to select that folder. Okay, that's great. And now I want to add this particular source. Yes, code. And I should be able to pop it up here for you guys. I'm gonna hide my terminal, my VS Code. There we go. Okay. So here is the VS Code for this particular project. You can see here, these are my list of files. I've got my license here. I've got my README. I've got my git ignore. That's great. Now let's do some work. In the obtain card. Okay, this is gonna get a little tricksy. And the obtain card here, we have this, is it obtain? No. And the repo card here, we have this website, which I'm gonna pull up, and it talks about a directory structure. This directory structure is really important. And you can see it includes PyFile build as well. So we're going to need to keep our development a little bit separate from our Python scripts. Now this is for a data science project. So I really like this example. However, we're not really doing a data science project yet. We might move in that direction. We still have to have this interface between the data that we're collecting and what we're doing. We still need the requirements. We're going to end up with reports and figures and references. We might not necessarily have notebooks, but we're going to have Py files. And those Py files should go inside this source folder. Yeah. So we have a license, make file that's going to compile our project. Eventually, we'll make a make file, and then we'll have the README, and then we need data. So I like to store my data separately from my project. Okay. So we're here. We're trying to figure some stuff out. The reason why I went to directory structure under repo with the VS Code work is we're going to end up adding some directories, and we can do that in the VS Code screen. So what I want to do first, I'm not going to add the data in. However, I am going to add a new folder, and I'm going to call this folder references. And inside this folder, I want to, okay, I'm back. My GPU, I'm so sorry. Okay, I did not lose the stream. That's good. That's Microsoft trying to access my admin settings. They say it doesn't affect your computer usage at all, but it does. I found that out in the event viewer. This references file I want to be called client interview. And I want this to dot markdown. So this is something that I'm going to include. This interview was conducted on Friday. Conducted on 2023.03.31. And there's a couple of things that happened. I'm just gonna write down some bullet point notes. We actually ended up with some drawings that are probably gonna end up in this references file, or in a document itself documenting our process. We need to set up a engineering notebook for this project. There's a lot of stuff that's going on because we're at this interface between code and physical objects and microcontrollers and whatnot. But this interview was conducted on this day. Client specified that they wanted to stream status poor. I am running a speed test on my internet right now. Error stream. Like, it would be great, YouTube, if you told me what the errors were. Um, I have no idea. I don't know what's going on. My internet says that it's fine. Uh, so I'm just going to continue and expect that viewers will experience buffering. That's great. If you were watching this later, um, I don't have any viewers right now. I am talking to a screen basically. And I had one viewer a while ago and they left like 5 minutes after the stream started. Um, anyway, so I am making some notes about the client interview that I had. This client interview was me talking with my partner about how they wanted or foresaw this project going. And that had, I'm not gonna lie, that had some very interesting communication barriers where I was trying to get information to figure out how to structure the logic of the code, and they were explaining the logic of how they wanted things to happen. And that does not always mesh very well. Um, so basically, client specified that they wanted to accurately determine battery charge and allow for charging up to a user specified number of batteries for each type. They described a modular system that incorporates a user determined amount of cubbies or a user determined modular system amount of modules for each battery type, and included a list of types for each battery type. I'm gonna put AA, AAA. They were very interested in getting their 18-volt drill battery done, as well as a lower voltage drill battery. They also drill battery. They also wanted flashlight batteries. I don't remember exactly what kinds of batteries those were because I do not personally use them. However, I do go through an inordinate amount of AA's, and I'm interested in charging my batteries at home because that makes sense. But I go through too many, and I would have to recharge and set up a cycle, and that's kind of what this is meant to do. This storage solution is meant to help users cycle through their batteries in storage and in order that will improve battery life. Okay, so some other notes. This project. This is such creepy music. I'm gonna skip this song. I don't. This song is called Cyberpunk Distressed. I'm gonna skip it because I don't want to be distressed. Maybe I want some interference, which is what this next song has to do, but I don't want distress. Will include, and by the way, for those of y'all watching along, which is probably no one, but that's fine. I just saw in YouTube that I can add a stream marker. So that's cool. And I can also create a highlight video. So that's cool too. Yeah. So I might play with that on my next stream. This project will include two major components. The microcontroller unit and housing, and the code base for user interface. Both will be open source. Kind of think of it like a IoT type project. And 3D printed housing. I'm gonna see why. Cool. I'm gonna add microcontroller to user settings. Both will be open source. The general idea is to set up a DIY approach along with an out of the box solution. So that's kind of why is this why let me see here. 4 problems. This sentence does not start with cancel. It's literally a capital letter. Microcontroller. I.e. Wow. Yeah. Okay, so that one makes sense. We can fix that one. Okay, that's great. This sentence does not. Oh, that one up there. Cool. This is supposed to be IE, I suppose. Okay, there we go. Oh, those are all in the README. Cool. And had nothing to do with what I was working on. That makes me feel a lot better. Okay, so both will be open source. The general idea is to set up a DIY approach along with an out-of-the-box solution. We agreed that what makes this particular project difficult is the number of and variety of voltages that need to be monitored. makes this project difficult is the number of and variety of voltages that need to be monitored, along with the potential for higher amperages. That is definitely, I'm pretty sure that's an actual word, amperages. Oh, wow, that's way too much copying. Amperage. Yeah, that's an actual word. So let's go ahead and can I not add add it to the dictionary? Okay, cool. So basically what happens with some of those 18-volt batteries is you end up getting around 40 amps moving through any wires that you have, and that can seriously damage a microcontroller, especially whenever they're only designed for like 10 milliamps. So that difference in current is difficult to navigate. And we talked about a potential solution to this problem is using a MOSFET. I don't even know if that's how you spell that. Let me find out. Mass. Yes, it is MOS FT. MOSFET. Is that? I don't even think that's right. MOS. MOS. Yeah, that's not right either. MOSFET. Okay, yeah, it's MOSFET. Is using MOSFET. Okay, done. This is spelling. Add words to workspace. No, add it to the dictionary. Add to a dictionary, please. Okay. So these are some of the things that we talked about. We also talked about, some discussion was had about how to obtain current charge information for batteries. Should one voltage sensor be used for the system, or should one voltage sensor be used for each battery? This changes the code a little bit. If it's one voltage sensor for each battery, then you would just iterate through the pens. And associated with that pen would be the voltage sensor. However, that's not exactly what we're going to do. It was decided that one voltage sensor should be used for the entire system. What that means for coding is we're going to have to check each pin and run that pin information through the voltage sensor in the microcontroller. So that changes our logic. It changes how we're going to shape or write the function that performs that task. And then there was some discussion about should users input which which modules have batteries and which ones don't. Is this something that can automatically be checked for? And you know, if there is nothing going to that pen, if there's no battery and there's no charge, then that means there won't be a change in that voltage. That voltage is just going to stay 0. And so this is something, yes, batteries with no charge, even dead ones, will pull on the existing electronics, changing the voltage state. So that's not something we have to check for. Again, this is basically us just getting our list of active versus inactive pens. And we're going to go with no. Users should not input which modules are active. Wow, this was a short page. Let's go to our next one. Okay. And then there was some big discussion here about how the system would work. And then we came up with this term called the dock, is the 3D printed structure that has batteries that actually houses user batteries. And then the battery charger. This is something that the user will provide. And basically you want to provide a charger that matches the battery that you're trying to charge. And we'll connect electrodes to. I don't know if electrodes is the right term, but basically you're going to connect your positive and your negative wire to the positive and negative ends of that battery charger. Because ultimately all battery chargers have this little metal plate that's on either end, and you need to connect electrodes to that plate to complete a signal. And what this does is it takes the power that's coming out of your wall and modulates it for what that battery is supposed to do. And so we end up creating a maximum threshold. And we'll never exceed that maximum threshold because that battery charger can only pull so much current from the wall. So this is going to end up protecting the system so that it doesn't overheat and stuff. Um, then there's going to be the dummy battery. This is 3D printed and will go into the battery charger. And honestly, something the user will provide that matches the battery type that they are trying to charge. Then there's dummy battery. This is 3D printed and will go into the user provided battery charger. With electrode connections to complete a circuit. This dummy battery will then connect into the main line, which has the different voltages. Another term that we came up with was the bus line. This is the negative for all batteries. And then on the positive line, there will be individual lines. These will connect to each battery in the dock for all batteries in the dock. These will connect to each battery in the dock. Yeah. So basically what happens with this individual and this bus line is we can provide charge, because that's what's hard about. We want to be able to read the voltage, but we also want to be able to charge the battery at the same time using the same line. And so that's why we're talking about implementing a bunch of step up and step down current modulators, basically, or relays in our system to be able to move between each space while providing enough current to do the things that we want to do without damaging our precious microcontroller that has our CPU that is going to house our code. What's important about knowing this setup is ultimately a series of pins will need to be activated and information run through certain sensors in or on the microcontroller. The particular one that we're talking about using is the one that we're talking about using is the Raspberry Pi Pico, and that particular microcontroller has a voltage sensor built in. What's interesting about it as well is that it has a I think it has a Wi-Fi connection. If it doesn't, it has like an SD card or USB or something that we can export a report onto, so that the user can get additional information. It's going to be a little bit further down the line, but it's great that it has a voltage sensor inbuilt. So that means less wire pen worry, I guess. Ultimately, a series of pins will need to be activated and information run through certain sensors on the microcontroller. That's what kind of creates our list that we're going to iterate through. And we have some information about what our function is going to look like. There will need to be a way for users to input information In this case, thresholds. A way for users to input information, in this case, thresholds. Discussion about percents or voltages. Percentages or voltages. Client is insistent about having voltages be the input. That's okay. So basically your AA battery can charge up to 1.5 volts. And if you want your upper threshold to be, this is like where the battery is between storage and use, to be 85, then 85%. I'm gonna put this here. For AA, the total voltage is 1.5 volts. And this is an example. It's not necessarily true. It's just to get the point across about what's going to be needed for code. The user wants to store between 1.0 and 1.2. Those would be the upper and, or let's do the lower and upper thresholds respectively. So we have those, we already know that we're going to be asking for an upper and a lower bound. And what happens now is we have anything from 1.2 to 1.5. This is going to be green on LED. Anything between 1.0 to 1.2 would be blue on LED, and then anything less than less than or equal to 1.0. No, I do not. No, I don't want to put an arrow. Less than or equal to is going to be red on LED. So that kind of tells us our, I guess, the return value for whatever our Python code is doing. We need to have these outputs communicated to the client via LED. And this this needs to happen for every battery. Now, this is something that we talked about too, which was a refresh interval. Should be no shorter than 6 hours, because it only takes a certain amount of time to charge a battery. And we also have to allow batteries charge. We have to allow those batteries to charge. Have to allow batteries to charge between reading cycles. I also want to say, and this kind of gives us our start condition, gives code a start condition. Maybe after a battery is charged, then it does a reading. If one is taken out of a charger, it does a reading. Like, there's a bunch of different start conditions that we can set for starting the code or moving to a different part of the code. Refresh interval should be no shorter than 6 hours. Have to allow batteries to charge between reading cycles. Gives code a start condition. Also informs that timekeeping is going to be important in the code. May need wait or sleep periods. frustrating to me because this is false positive. I don't know if I can get rid of this. Hide false positive. There we go. Okay. I'm gonna say it instead. Jeez Louise. False positive. Okay. Let's see here. I'm trying to remember what else happened in our interview from that day. I don't think we talked about anything else that particular day. We definitely decided that this is the difficult part of this particular project and why it hasn't been done before. We talked about web application for user to input information. This is from today. So I'm gonna put 2023.04.03. And then on the following day, maybe it was even later that night. It was on 0401. I got a series of websites to check out, and I got some notes as well. Okay, client tools, max chargers are about 24 volts, 21 actual, and 13.5 amps. I'm gonna put spaces. I don't normally put spaces, but I'm going to here. So need a transistor that can handle approximately 40 volts and 15 plus amps. And then they provided a link to a possible solution that fits those criteria. And then for 18650s, I believe this is flashlight batteries. Example user settings, keep between 3.64 volts and 3.71 volts. Keep above 10C. Keep X number of batteries fully charged. And then they provided a link as well for some information there. And then some additional commentary. The 18650 chargers need maybe a 5 amp, 5 to 10 volt rated MOSFET. And then they provided a link with an example. Then they have this comment, wonder if the bigger one, in this case the MOSFET, will work with the smaller voltages, loads. So only one version of this is needed. And then I'm gonna put in my own comment here, which is increasing modularity. And then they have a comment again for AA's. Here's for AA's, and then they have some information that's not needed for this commentary, which is price. That's not something I really care about as a coder. For AA's, here's a 8 volts max with 3 amps. And then they have a link here. And let's see. Then there's a bunch of other stuff from today. We talked about the web application. The first thing that I did, so this is all information from the client. I'm gonna do, and I'm just gonna put the date. Here is the header. And then we have this, there we go. I don't know what was happening there. We have that date, and then we have today's date. This is what I sent to client. Copy link. I sent this link to them. It's the top 5 best microcontrollers for Python. And they had mentioned on this date up here, client wants a microcontroller to be flashable. I'm gonna add this to the workspace. Flashable to dictionary. There we go. And there's one in the article that it mentions being flashable. My observation from this link is that it's called MicroPython will be necessary. We're gonna add this to the workspace settings. We're gonna add that to the dictionary. Will be necessary. The web application for user information came up today. Wi-Fi means sending emails when something happens, or weekly reports. This could pop up like this Wi-Fi connection means, sure, let's do the official spelling of Wi-Fi. This is from the client. From client. And then they included a then we did later was the conversation about web apps. From client, they went into a crazy rabbit hole. And then they said from client, I like the idea of broadcasting a Wi-Fi signal, connecting it to my phone, and setting the user inputs that way on a self-hosted website, or the web app in this case. And so this is kind of my observation from comment, a web application for user to input information. And then from the client, there was some versus connecting to existing Wi-Fi and figuring out how to do all of that as securely. And then there was just a break. Either case, Wi-Fi is helpful. I know nothing how to implement any of that. This is why they asked for my help on the project, because I do know a little bit about that. And then the next comment that they had today was just confirming from client, they found a way to get the particular product that we're looking at, and then they sent kind of a for fun video about the particular device, then talking about we can just start with a kit. Then I got this long commentary from the client about 23 usable GPIO appends. 3 are more weird. They have more functionality. Those three weird ones can measure temperature or voltage. We can control transistors, MOSFETs, relays, whatever. So with this particular board, we can charge 24 batteries max. 1 weird for voltage check, 22 for battery relays, 1 normal for 1 weird relay, 2 weirds for last 2 battery relays. And then can't have a separate temperature sensor. So we just have to measure and adjust from the embedded temperature sensor. Then a voltage tester trial. Anything above 3 volts needs other stuff to get it within testable range, which is the step up and step down stuff. Um, and then they actually went out and found another GitHub system that uses the Pico to check for voltage. Then there is more information from the client. And then they have some more information here. So this is what's really cool, I think, about projects like this. As you just start talking and you provide a simple piece of information, like this is, like today, I started off with, after getting this information dump yesterday, that's like, a lot of this is kind of like Greek to me. I really don't understand electrical design very much. I'm not an electrical engineer. The partner that I'm working with is an engineer. They understand it a lot more than I do. I at least know how to calculate for voltage and amperage, and that was part of our conversation on the very first day. Was he kind of like refreshed me on voltage equals current times resistance, and then we talked about power as well, and it being a function of work done, which is some relationship between voltage and current. And we talked through part of that process so I could at least follow what he was doing enough to figure out, do I have to create a variable for this in the code? And then today I sent this quick today I restarted the conversation and I sent a link to find out which microcontroller would probably be best for us to use. And I just said, you know, these are the ones that work best with Python. This particular one I'm interested in because, what did I say exactly? Oh, that it was flashable, which was one of the client's requirements, was that the board, the microcontroller that we use be flashable. I don't know what that means. I probably should know what that means, but I'm not super into that particular side of coding. But I did find out the Python library, or at least version of Python that I will need to use, and that the microcontroller can, basically what language do I have to use so that the microcontroller can understand the inputs that I'm doing. So it's going to be MicroPython, so I'm going to need to do some reading about how to implement MicroPython. So I'm going to hide the false positive, hide the false positive, hide false positive, Pico, what? Hide the false positive. These are all like direct quotes. I don't know what's happening right now. I don't know why. None of these are going away. Anyway. You are currently up to date. Some of this information has actually come up during our stream today. This last input here is current controlled. MOSFET is voltage. We have some outputs. We can manually change it. Again, the microcontrollers work in milliamps, but we're going to be working with whole number amps, and the difference between that is 1,000 times. So we definitely don't want to fry our microcontroller as we're trying to charge these batteries. So we're going to have some step up and step downs. I know that. But it also means that our microcontroller might be running hot. And so that means that these sleep, I can't remember where it is, but these like sleep intervals are going to be really important for cooling down our microelectronics. Except charge is going to be flowing through, so we're going to have to kind of figure that out. So that's kind of the gist of the client interview. Now, the reason why I wanted to stream this portion is how do I take this client interview and start turning it into user stories? And after turning it into user stories, how then do I create sprints? So as far as users go, the users in this case are my end user. Then I have the client. And then I have myself as a software developer. The other position that I can immediately see coming up is a cloud architect. I can immediately see these things. And then there's going to be some front-end considerations. There's also going to be some back-end considerations here. There's also going to be some engineer, some microelectronic stuff. So electrical engineer. I'm also going to put that microelectronic. What is that? Are they engineers too? Microelectronic. Engineer? Yeah, I guess so. Microelectronic engineering. So these are the different users that I can automatically see happening. Most of the stuff that I'm going to be writing about is from the back-end software developer standpoint. I will do some front-end stuff as well. Cloud architect, I think that we're going to have to outsource that between me and my partner, and then my partner is going to fill the roles of electrical engineering, microelectronic engineering, client, and end user. So those are the different users. Let's go ahead and set up some labels. I think I have these as blue, light blue. Yeah, I have these end user, and I want this to still be light blue. The client, create new label. I'm just gonna say front end. Create new label. Backend developer. Let's add developer. Okay, and then and then we have our electrical engineer and our microelectronic engineer. Okay. So these are different users. This particular card does not need all of these labels, but users are blue. And whenever we make our cards, we'll be able to attach a user to them. Now, our project, after going through all of that communication between me and the client and the interview, or discussion that was had last Friday. This project is to set up a system that interfaces microcontrollers and user configurable options to store batteries for a long time period. The system will provide storage information via RGB LED lights about battery status, i.e. not charged, charged, and stored. That's actually a pretty good summary of what the goals are. So now we're starting to move to user stories. Let's do... Shoosh, man. Where to start? Okay. Under repo, we know that we want this structure. So as a, let's do, for this card, how will the client be interfacing with the repo? Ideally, they won't be. They won't have to interface with the repo at all. For the PI files, they will want to start the process. They'll need to be able to do that. As a end user, I want to start the battery storage process so that my batteries are optimally store. I want to start the battery storage process so that my batteries are optimally stored with voltages that I input. Now this particular client or this end user story is going to inform what we do under this idea of start the process. I guess that is something that I forgot to put in my client interview as we talked about whether, okay. We did talk about whether or not to include a hard reset button or start button or something. We did state this. We wanted to figure out whether or not to include some stuff. Let's see here. As an end user, my acceptance criteria is going to be when I put in a battery, I can tell that the system has recognized me adding a battery. And user want to start the battery storage process so that my battery is, we're going a little bit smaller, is optimally stored with the voltage that I input. I want to start the battery storage process is optimally stored. That with voltage that I input is a little bit too complex for this idea. So here, maybe when no battery is present, all LED lights are off. When a battery is input, the LED changes to red. on the next cycle. That's my idea for this as a software developer. So that's kind of how this whole process starts. And now that I have started the process, I want to input my thresholds. This is again going to be an end user. Labels, end user. This is going to be an end user. I want to input my battery thresholds so that, and again, this is so that let's get our comma. My batteries are charged optimally, and they want to input my battery charge thresholds so that my batteries are charged optimally, lengthening their lifespan. Our action result for our acceptance criteria is going to be after inputting my desired thresholds, I can see that the system has logged those thresholds. So this would be like after input is received and stored in the appropriate variable what is an output is shown after input is received and stored in the appropriate variable, and output is shown telling the user that the variables have been logged. This would be in that web application. So this is an end user label, but this, you can tell, will turn into a front-end developer user story. Okay, so we've started writing end user user stories associated with the Py file, Py files. And the reason why they're in the Py files is because they want to start the process. We want to store some values. Those are going to happen inside the Py files. However, I think these should actually be in Obtain, which is kind of like the data science equivalent of instantiating the whole project. Okay, so these would then move into sprints later on. Basically, what I'm trying to get at is I need to add a ton of these user stories to start the project. However, this stream has been going for a long time. Yeah. Like 2 hours. So I'm gonna quit here for today. And I hope that you have enjoyed what starting one of these project boards looks like. We've started the process at this point. You know, after my client interview, I'm going to write up a whole bunch of user stories from the end user or the client perspective. And then from that point, I would ask, instead of end user client, I'm actually gonna change that to just end user labels. I want to, let's delete this particular label. I would ask, me as the manager, I'm writing these end user stories. So I'm gonna say that the project manager or owner write these, and then the variety of teams that you might have collaborating, they're going to write their own user stories based off of your project manager or end user stories. And then from that point, that's where you develop your sprint, is after getting feedback from the people on these variety of teams. So yeah, I'm going to stop the stream because I'm tired and hungry and it's dinner time. And my location, and I hope that y'all have enjoyed this for what it was. And I hope you have a good evening. All right, see y'all next time. Bye.